Alright, thank you so much for coming back. And, I want to say thanks so much for all the people donated to the program. It means so much. It helps a lot to keep this project going. You know what I'm saying. I'm nothing without you. Okay, so thank you so much for the people donated $1, $100, $50, to $1,000,000. Sometimes you guys send me so much. I kind of felt like, oh man, it make me feel like you appreciate what I'm doing. So let's get started. So we have f(x). This is step function, just like how we see x, whereby x less than 1, x minus 1, x squared, whatever. Draw the graph. Okay, let's draw the graph. Very easy. So drawing the graph, this is how we're going to draw a graph. Okay, excuse me, just a second. Let's draw a graph now. So first and foremost, I'm going to draw a table value. It's not necessary, but I like to draw table value. If I don't want, you can just do straight away too. So either two things. Either you can skip table value and then you can draw straight, but for the people who are in slow pace, you can just draw your table value. Okay, so I'm going to say my table value. So I got two table value here. Okay, the first table value, you know what I'm saying? So first table value. Okay, so what I'm going to do, I'm going to draw my table value. Okay, so I'm going to draw my table value. Okay, so I'm going to say, let me draw the first table value. So this is x, and then the first function is going to be f(x) equal to x. But we're going to take all the value of x which are less than 1, means it can be 1, 0, negative 1, because we take all the x like 1, 0, legs are less than 1, 1, 0 to the negative. So function equal to x, our function, so the value of function equal to x. But which value we're going to take? We said start from 1, and there we go, 0, negative 1, let's say negative 2. Negative 3, negative 4, negative 5. Just sum. Okay? So what we're going to substitute? We're going to substitute in this function, which is what? X. Okay. So if we substitute this 1 in x, what we're going to get? Of course, it's going to be the same value. So value is going to be the same. If we substitute this value of x in x, going to be the same value. Negative 2 is going to be negative 2. Everything is going to be the same value, same value. You know what I'm saying? So we're going to do the same thing, but another table value. It's not much to draw table value, but this is for sometimes some people, they kind of get confused. X minus 1 what? Square. So here x minus 1 square, but we're going to take the value of x start from 1 and more than 1. Oh, okay. So x, but f of x equal to x minus 1 what? Square. Okay, so we say we start from x equal to 1, 2 because it's greater than 3. There you go, 4, 5, 6, 7. Just sum. You know what I'm saying? Now let's plug it in. So now x equal to 1. So 1 minus 1 equal to 0, 0 square equal to 0. Now we got 2. Okay? X equal to 2. 2 minus 1 equal to 1. 1 equal to 1. 2. 3. 3 minus 1 equal to 2 square equal to 4. 4. 4 square minus 1. 3. 3 square 9. Okay. This 5. 5 minus 1 equal to 4. 4 square equal to 16. And this is going to be 5. 5 minus 1 is going to be 25. And this is going to be 36, etc. etc. Okay, now let's draw a graph. So when you draw a graph, you gotta be very, very smart here. You know what I'm saying? You wanna be smart. You don't just want to draw and then make mistake. It's not good. So I'm gonna draw my Cartesian plane. Say okay, let's draw a Cartesian plane. This x and this is our y. Okay. So now we say, well, let's get started. So the first coordinate here, you gotta be careful. So come to your graph, start with the first coordinate. The first coordinate x including 1. For the first graph, including 1 means this is including. Okay, so when x, make sure you go to first point. The first point x1, when x equal to 1, what the value of y? Y equal to 1 also means 1 and 1 here, but it's including, so you must put solid. Okay, 0, 0 means here. Okay, now negative 1 means negative 1, negative 1 is here. Negative 2, negative 2, can you see negative 2, negative 2 means negative 2. So this graph go this way. This is a rough sketch. You know what I'm saying? It means straight. Like now we go for the next one. For the next one also, you start with the first point. So for the first one, for the second one, look, the first point is start from x equal to 1, but excluding x excluding. Okay, x also start from 1 for this also. You know what I'm saying? But excluding. So if this is 1, y equal to 0. Oh, if x equal to 1, y equal to 0 means here. But it's what is excluding. So excluding means you just draw like a ring. Okay, when x equal to 2, y equal to 1. When x equal to 2, y equal to 1, somewhere here. But remember, this is going to be quadratic because there's a square there. Okay, when x equal to 2, 3, 2, 1, 3, 4, let's say this is 2, 3, 3 is going to be 4, 2, 1. Say this is 2, 3, 4, somewhere here. So, okay, 4, 9, so let's see, 4. So it's going to be like parabolic. You know what I'm saying? Because it's quadratic, remember, okay? So now we have drawn our graph, okay? You know what I'm saying? Here is including, here is excluding. Now, what do I want us to find now? So here in the question, they say determine f of x, x approach equal to 1 from the right. When you say x approach 1, see, when you say positive means it's from the right. Okay, so either, okay, let me do without graph, and then I can do with the graph. Let me just show you. Let's say you did not draw a graph, let's say, because sometimes if a time too small and they did not ask you to draw a graph, means you can answer without even drawing graph. So I'm going to answer for you, you know, without graph and then with the graph also, on just identifying the graph. So without graph, you know how I'm going to do? Look, I'm going to approach 1 from the right. Come here. If you look at this is without graph, you know what I'm saying? If you look careful here, right? When you say x less than 1, what does that mean? This is a number which like 0, negative. So this means you approach 1 from the left, because when you say 1, 0, negative, mean this is like you approach 1 from the left, because look, from the left, because this number goes to the left. So it's like if you come, you're gonna come from the left. Okay, so this is for this. You know what I'm saying? So this is for this. Okay, and when is 1, when you put here 1, what you're gonna get? You're gonna get what? 1. So that means this, for this approach 1 from the right, it has to be for the second one. You know what I'm saying? You know why? Because look, x is greater than 1. What does that mean? Means 2, 3, 4, etc., etc. So if you approach 1 from the right, means you're gonna be coming from this group, not that, because x is greater than 1 means 2, 3, 4, 5. So if you approach 1 from the right, means of course you're gonna be, this is gonna be the group that you're gonna use, not that, because this is like it's gonna go to the left. So you approach 1 from the right. So this, if you have a 1 here, okay, it's gonna be value of x equal to 1, because your limit is gonna be equal to 1, right? 1 minus 1 equals, so you're gonna say this is same as, say, let me say this is same as, this same as, say, equal to limit x approach equal to 1. But what is the function? X minus 1. So x minus 1 squared. But what is our value of x now? We're going to substitute to replace this x equal to 1. So it's going to be 1 minus 1 equal to 0. 0 squared equal to 0. So our right limit from the right equal to 0. Now let's go for the other one. So now for that case, now this is like without graph. So I can write separately just in case, you know what I'm saying? I can just say, okay, so now limit from the right, limit f of x, x approach equal to 1 from the right. What is that? We say from the right means this one, x, because this is the one, x minus 1 square. So this MSA limit x approach to 1, x minus 1 square. Choose my handwriting there, my apology. Okay, it was too small. So now this, let me say limit x approach equal to 1 from the right, but this going to be x minus 1 square. Now x equal to 1, because when you limit means you have to replace this with the value of x, which equal to 1. 1 minus 1 equals 0. 0 square equal to 0. So this is for what? For right hand side limit. Now let's go for the left hand side limit. Left hand side limit, this going to be limit f of x, x approach to 1 from the left. What is that? When you say from the left, it's obvious this one from the left, which is this one, x. So I'm going to replace f of x and put what? X. So I'm going to say this, let me say limit x approach to 1 from the left, but it's going to be x. So what the value of x? Replace with 1. Put here 1. Remember, this is from the right, and this meaning from this from the left and this from the right. So put the value of x, x is going to be equal to 1. And when the moment you put the value of limit, don't write limit anymore. Oh, so limit from the left equal to 1, but lift from the right equal to 0. Okay, so for that case, this limit is not going to exist, because which limit is that? Why you say this limit? What you mean? The limit, excuse me, okay, Okay, before I go to conclusion, now let me show you with the graph now. So we have known already how to read a limit from normal without graph. This is what like I was assuming without graph. So for any limit to exist, for any limit to exist, it has to be for limit. No, that's going to be the third one. B. Okay, let's go for the B. Excuse me. They say B, determine whether if this exists. So you know what? For this to exist, C equal to 1. So for the 1 to exist means 1 plus 1 from the right must exist. It must be the same with the 1 from the left. When they're the same, then this, the one with no left or right, is going to exist. But for this case, we see the 1 from the right is 0 and the 1 from the left, we got 1. Since they're not the same, so these cannot exist. You know what I'm saying? So we're going to say now, okay, so we're going to say, now, so how are we going to conclude? We're going to say, okay, we got you. So we're going to say a limit, let's say here, does f of x exist? Hell no. Doesn't exist. No. Limit f of x whereby x approach equal to 1, it doesn't exist. Does not exist. Does not what? Exist. You know why? Because the limit from the left, because the 1 from the right, because limit f of x approach equal to 1 from the right is not equal to limit f of x approach to 1 from the left. So if these, you see, 1 from the left, 1, if these from the left and right, which is the same number as this, which we have limited, if they're not equal, it's like the one from the right, it was 0, which is not equal to 1. So for that case, this does not exist. You know what I'm saying? But if it was the same, then this means it does exist. Okay? So that's how you do. Now let's go for the next one. So for the next one, let's say is f of x. Let's say if f of x continues or not. It does not continues, because for the function to continue means there must be okay, before I do that, excuse me, I say I was going to show you with a graph, so you gotta be fair. Let me show you with a graph now how to check a limit. Okay, look, we say we approach 1 from the left and 1 from the right. Okay, now look, if I approach 1 from the left, means I'm coming here from the left. Which graph I'm going to bump in first? I'm going to bump this one or this one? Of course, this is the one I'm going to bump. So this, if I approach 1, this is our x equal to 1, because we want to approach what? 1 from the right and 1 from the left and 1 from the right. If I come from the left, look, I'm moving like with the snow plow, with a plow. So now I'm moving. You know what I'm saying? Or with a grader. Okay, if I come with a grader or whatever I'm coming with, means I'm going to bump this one first. So if I'm bumping this, means if I approach 1 from the left, this is the graph I'm going to read, not this. This is the one, because this is the one I'm going to bump it face. Okay, and what the value of this, you know what I'm saying, which is straight line, remember. Okay, so when I approach 1, if it's 1, it's going to give me what? Look, for the straight line, if it's 1, it's going to give me the same 1. You know what I'm saying? So means limit f of x approach to 1 from the left is going to give us 1. And which function I'm going to use? We know for f(x) I'm going to use what? X. But if I'm going to move now from the right, look, but approach 1, the same value, which is x equal to 1. Now look, if I'm coming from this side, I'm going to bump this graph, which is parabolic, which is this one here. Oh, so if I bump this, means I'm gonna my reading is gonna be on this, not on that, because this is the one I'm gonna bump it first. So I'm gonna read what the value of y equal to 0. Oh, so limit f of x approach to 1 from the right is gonna give me equal to 0. You know what I'm saying? 0. And since left hand side is not equal to the right hand side, means since this is not equal to this. So I'm going to conclude, but you have to write aside, right? I'm going to conclude that limit of f of x approach to 1 with no from the right, from the left, it does not exist. It doesn't exist because these are not equal. But if they're equal, yes, it does exist. So it doesn't exist. You know what I'm saying? So now the ask is here, is f of x continue at the same value? No, it does not continuous, because for this to continue there's a lot of condition. One of the condition, it must exist. So since it does not exist, means it cannot continue. You can see here, look, this graph came all the way and then it kind of disjoint with this. You know what I'm saying? So it means it's not continuous graph. It means it came here and then it stopped and then it went to another point and then it went another one. So it's not continuous graph. It would be continuous if this one stopped here and then there's another one, let's say here, and they'll say yes, it's continuous. And condition, either both of them, they have to be included, like let's say included if it's happen like the graph is joined for continuity. You know what I'm saying? Means this must be including and including, or one of them either it must be including. But if both of them are excluding, like let's say no, it's not continuous because it's going to have a gap inside. You know what I'm saying? So either it can be like this, it's okay, or it could be both dot. But if it's happened like this, no, because it's a disjoint. You know what I'm saying? Means it's not continuous. You know, but that's not part of the question for now. So we just ask, is f continuous x is to 1? Yes, it's discontinuous. You know why? Because the reason for this case is because the limit on the left hand side is not equal to the limit on the left hand side. So the reason we say is not continuous because f of x does not exist. So I can say, oh no, because it doesn't continue, it does not continue. Because f of x limit x approach equal to 1, right? Yeah, 1, it doesn't exist. And we know how it's gonna exist. Means limit on left hand side means limit f of x approach to 1 from the left is not equal to limit f of x approach to 1 from the right. Easy, man. We out here, baby. You know what I'm saying? Let's always do this question, man. Very, very easy question. You know? Thank you. Thanks a lot for your time. I appreciate it, man. You know, like I said, you know, we do this in a project to motivate a lot of people, and I truly appreciate your praise and your donation. Means I'm happy. You know, it's a lot of people who are new here in this channel, you know, in this program, okay? So if you first time right here in these intellectual things, intellectual property, come right here, see here, subscribe and leave a comments. I'm gonna be more than happy to help you. Another things, again, I want to say thanks so much for all the people who donated to me, who donated. It means a lot. It's a lot of money you guys are saying to me. It means a lot because you know I got a lot of projects that we're doing, feeding the people, homeless people, motivates, taking all these kids from the street and bring their dream to reality. So thanks a lot for all your donation. It means a lot. Look at most of Sub-Sahara. If I give example, for example, South Africa, a lot of students that have a problem with mathematics, so mathematics and science. And you know, for the world we live in, we need a lot of people who do science and research because of the things like we're facing right now this year, 2020, like corona and stuff, and people that have a shortage of doctors, that have a shortage of engineers and stuff, and even other causes too. But my main focus is engineering, science, math, and computer programming and coding like Java, C# and PHP and JavaScript. So this is gonna be the main focus. So now we're gonna drop the app very soon. So you can we're gonna put like subscription fees, which is very reasonable, where you can access all the materials. So we're gonna have courses where you can purchase the course. You know what I'm saying? But of course, this is for free, and most of the material here is very accessible. Same with this, but it's light. Some of the course is gonna be for free, and some of the course, depending which type of course. But our main focus is to serve a lot of people, from various places like corporate, you know what I'm saying, the corporate world. So serve a lot of people, and also going to be traveling, go to various places. So 2020, I'm going to be traveling to a lot of countries. You know what I'm saying? I got invitation, a lot of countries, man. You know what I'm saying? So you will see me in your town, in your village. You know, I'm a village boy, so you know I'm gonna go to the village and go see a lot of places, serving a lot of kids, share with them, teach them knowledge, and that I can change their life. Okay, that can bring change to our society. Okay, you know what I'm saying? So Pamoja Milali Academy, the app is gonna drop very, very soon. You know what I'm saying? I got a big team. So just stay tuned. I'm gonna announce when the app is gonna be dropped. I believe that most of the people that have a smartphone. So it's gonna be easy for you to access the app. Yeah, you will get, I don't want to say a lot, you will see some things a lot for your time.